Welcome to the project demonstration of IoT based smart electricity meter. So in this project mainly we are using the features like smart electricity monitoring like energy, power and frequency, voltage. So these are all parameters will be monitored continuously by the ESP32, and also if is there any heavy load detected by this module, the system will send the SMS alerts to the registered phone number, like heavy power consumption, heavy load was connected to the system. And also the so-called status continuously monitored on the ThinkSpeak using IoT cloud platform. So there we get the parameters from this system for every 10 to 15 seconds of duration. The parameters like voltage, current and power of this load which was connected, and energy, how much of energy was consumed till now, and next frequency. Totally these 5 parameters along with power factor also. So in this one we have added the power factor also. Totally 6 parameters: voltage, current, frequency, power, energy and power factor value. So there are 6 parameters continuously monitored on this OLED display as well as to the ThinkSpeak and also SMS alerts. So coming to the these are the main features, and coming to the components to achieve these features. So first of all we are providing the 230 volts AC input to this regular power supply board as well as to these 2 loads through this PZEM module, which is main component to monitor these parameters. And these loads can be handled by this one is up to maximum of 100 amps, but for the demonstration purpose we kept the limit for the high load alert is to 150 watts. So whenever the 150 watts load is more than that, the load was connected more than 150 watts, then the system will isolate the power supply to these loads and also sending SMS alerts to the registered phone number by using this GSM module. And there is a buzzer to provide us the audible alerts whenever this abnormality of load detected when it's crosses threshold value. And as we discussed this PZEM module, OLED display, and this is the breadboard to distribute the 5 volts power supply which is getting from this one. So which is take 230 volts AC inputs and provide us a 5 volts DC output. And next this is the electromagnetic relay which is used to isolate the power supply and connect the power supply to the loads. And this is the toroid ring, so nothing but the CT to measure the currents and current waveforms directly. So let us see the demonstration. Before demonstration, first of all we need to on the hotspot in your phone. So for that just configure the hotspot name to project 7239, right? Okay, so project 7239 without any space, without any capital letter. Password should be 123456789. After configuring the hotspot and AP band should be 2.4 gigahertz. Okay, so after these 3 settings, on the hotspot along with data. So after enabling the hotspot and data, now log into the ThinkSpeak cloud platform. So just log into this ThinkSpeak cloud platform. So this is the old data. So if you want to erase the old data and get the new data to be uploaded, then before erasing this you can take the backup. So for that, data import export and download the data. So it will download it in Excel sheet and open that. So it will get opened in Excel sheet. So it consists of date and time and how many samples till now collected. So now we have till now collected around 180 samples we have till now collected in my graph. And the first one is, as we discussed, voltage, current, all these are present over there only. So now after you took the backup, now go to channel settings, data import export for download the data. In channel settings only do clear channel, don't delete that, only clear the channel. Right, now it's got cleared. Now go to private view. There you get the old data got erased, but the fields are present only. These graphs will be there, but the old data got erased. Now on the power supply to this, sorry, before that again. So after enable the hotspot and log into ThinkSpeak, you can clear the data. Next thing is insert a SIM card. So we are going to use the SIM card through that only we are going to send the messages. So here push to lock and push to unlock. The notch should be this side. Use VI or Airtel without other than Geo. So now the notch should be this side and push to lock. Okay, so after that you can on the power supply to the system. Just on the power supply, right? There you can see one light will blinking on this near the GSM modem. You can write, see that red light. So initially it is blinking at duration of 1 second, So after SIM card got the signal, the blinking rate will be slowed down. Now you can see that the blinking rate got slowed down. On LCD we can see the data also, OLED sorry. So the energy, frequency and power factor values and voltage and current and energy, power, right? Okay. So now the 100 watts bulb got connected on this one. We can see that 100 watts bulb. So that's why it is showing the power of 119 watts. Okay, as we are using the resistive bulb, that's why the power factor value is showing 1 only, unity power factor value. Right, okay. And now, so it's a continuous process. We can connect any load here, okay. But we set the limitation, right? We got the readings into this. So when you click on this, so we can see the voltage and next current and the power. So how much of power was connected over here? So you can check that's 119. And next energy and frequency and next power factor value. Okay. So now when we connected this load, then the load will increase. Right. Okay. So as a 200 watts of load connected, that's why it's of the relay, and it will send the message alerts to the registered phone number. So to this number we are going to receive the right. We will receive the message. Power exceeded 150 watts. That's why we have isolated the power to that one. And now whenever we keep it normal again, just you can disconnect this. Okay, and you can reset the system. So this is a reset switch. Right, it will be on again. Right, so it's a continuous process based on the power consumption. So in this way we are going to get the IoT based electricity metering system. Right, okay, thank you.